All right, welcome everyone. Today is Wednesday, the 13th of December, 2023, and this is the Cluster API Karpenter Feature Group meeting. This is a sub project of Cluster API, and as such, we follow the CNCF's guidelines for Kubernetes SIGs and meetings, which basically means please treat everyone as you would expect to be treated, or explicitly so. Please be kind to each other. And if you'd like to talk, please raise your hand and I'll call on you. So I guess I got a little bit slow here starting the meeting off today. So let's get this updated. And I had added a topic that I wanted to get into because I thought it was interesting at the meeting last week. But I'm happy for any other topics that people might want as well. So the topic that I wanted to kind of get into, and please add yourself to the attendees list if you are so inclined. You just need a HackMD account to add to this document, but you can use like your GitHub credentials to make one. So yeah, what I wanted to talk about was machine deployments and kind of the topic that Fabrizio had raised during the last regular Cluster API meeting, because I thought it was really interesting what he was talking about. So to refresh that a little bit, during the last Cluster API meeting, I brought up the topic of machine pools because I was thinking, and I think we talked about here that machine pools seemed like a very natural way to bring, kind of integration between Karpenter and Cluster API. And I think part of that might have been based on my perhaps optimistic reading of machine pools that they could be used to, to collect heterogeneous collections of machines as well. I think like having the discussion upstream, brought out some of these details. And I think people were like, they're like, okay, yeah, they could be heterogeneous collections. But one of the things that Fabrizio brought up in discussion about that was the notion that perhaps machine deployments could be expanded in a way to where they could understand more things, or there might be different modes that a machine deployment could operate in, such that perhaps a machine deployment could contain multiple instances or instance types. And this is something that I think users are looking for this kind of functionality, especially when they talk about wanting like backup machines and wanting it to fail over to pick the right one and those kind of things. So I've been doing some investigation to kind of figure out like, what would this look like and whatnot. And I could see a lot of different ways to do it, but I wanted to talk here and just see like, does anybody have thoughts about this, or has anybody kind of thought about the idea of what if we added modes, to machine deployments or something? And if not, I'll just keep talking. Yeah, Jack, please.
Thanks, Mike. Okay, great. This is a great topic. So as I'm looking at some machine deployments now. Sorry, I'm not sharing them with the folks, but I'll try to describe them. And it's not actually clear from a machine deployment, like an actual machine deployment that has an infrastructure ref to, insert infrastructure here, machine deployment that it's homogeneous right now. For example, the homogeneity, you have to follow the infrastructure ref to start getting to a data structure that is sort of explicitly homogeneous. So I'm seeing a replica count. So a replica count maybe that suggests homogeneity, or maybe it just literally suggests the number of machines that this machine deployment has a reference to. So I guess I wanted to talk about this mode thing. To me, the mode property, I assume it's a kind of like top level property of a machine deployment, would represent not only a particular, like not only a particular semantic value that suggests what type of machine deployment it is, but it would also sort of try to contextualize homogeneity versus heterogeneity. So particular modes would sort of implicitly express that this is going to be a heterogeneous thing. Is that right? Is that what we're sort of taking from Fabrizio's suggestion? Mike Climo?
Yes, that is exactly what I was thinking, was that like if we follow along the guide that like Fabrizio was talking about, I think it's exactly what you're saying. Like somewhere in the man, these windows get stacked and then I can barely control anything here. So somewhere, you're right, like somewhere in the spec, we would at the top level probably we would have some sort of mode for the deployment, right? And exactly what you're saying, that I I'm going to say things now that probably would never be in the API, but that's just the way we're talking about it. Like, yeah, the mode might be homogeneous or heterogeneous, right? And then that might tell you that, we might need to update something here so that you could have, multiple templates or something, or there's going to be some way, there needs to be some way for us to be able to say, if I'm setting this to a different mode, then we have to be able to enumerate the templates that are in here, or the machine objects or something, right? So like somewhere in here, we're going to have to be able to change something to make it, or probably add something so that if you have this type of field, if your mode is heterogeneous, we can't just say now it points to one, machine set or whatever. Like we have to be able to do this across multiple different types of machines and then enumerate the types, from the machine deployment.
Okay, cool. So maybe this is getting to the heart of the matter, which is that is there a contract that says an Azure? Sorry, I'm saying Azure because I'm looking at an Azure example. Is there a contract that says that an infrastructure machine template is intrinsically homogeneous in terms of its child machines?
I love what you're thinking there. I
Because
don't
I'm
think
not
so. I
sure.
don't
I'm
think
not sure.
there is.
As I
Yeah.
read it, it's not clear that it's the case. Like
I love.
why can't the machine template itself carry the heterogeneity?
Yeah, I love that.
I mean, as I read an Azure one, and I imagine it'd be the same if I brought up an AWS or a vSphere. It clearly reads like a thing that is meant to be replicated across a single common machine formula. Like you've got a VM size or instance type in AWS. Like these things, if you say instance type equals this static instance type, then it clearly suggests that like every machine built from that template is going to have that instance type. But if the infrastructure machine template carried an array of like instance types, then you can start to see how heterogeneity could like spring from that.
Yes.
So the only reason I'm bringing all this up is to maybe consider like maybe we don't actually need a new data type evolution for the CAPI machine deployment and machine pool specs, and instead, if the infrastructure refs that those machine deployments or machine pools follow carry the sufficient heterogeneous properties, then we can actually continue to just push this into the infrastructure. The problem that I have with this is that the key, I'm not sure how to reconcile that with the sort of ideal North Star where we have a single Karpenter provider that spans across all infrastructure providers. So it's not AWS re-implementing the Karpenter provisioner in CAPI, and then the same for Azure and the same for GCP, et cetera.
Right. But so that makes me think, and please, if anybody else has thoughts, please raise your hand. That makes me think that at the CAPI level, then, right, like we would probably want some sort of new infrastructure type that speaks to this. And then like you could at least detect based on which one you're looking at, what kind of behavior you should get into, right? I don't know how feasible that is though, given like the state of the API and everything. That's why I really love what you're talking about here with the infrastructure object, because it seems like that's a way that we can like put more detail into the existing API and then build our business logic out to kind of like detect it and do the right thing.
And maybe if there were a Karpenter machine template, which itself carried the infrastructure specific componentry. So the machine deployment or the machine pool, let's just stick with machine deployments because it's the most common. Machine deployment points to a Karpenter machine template. And that has information like, infrastructure equals AWS, something like that. And then that can reference specific AWS machines. So the idea here for folks who aren't following is we want to be able to take advantage of all the existing provisioning logic that is already implemented in the provider ecosystem for CAPI and not have to implement. So the Karpenter, yeah, I feel like I've talked a lot. Does anybody else want to speak to this, or maybe we move on to the next agenda just so it's not Mike and myself?
I'm not sure that we have another agenda item, so unless someone wants to add something.
Cool. I've got a 30 minutes past the hour cutoff, so I won't talk forever. Promise that.
I mean, does anybody have an objection to Jack and I just continuing to talk here? Because I don't want to. Yeah, I agree with Jack. I don't want to make this just the Jack and El Miko show or whatever. If anybody wants to jump in here, please. Okay, well, while people think about it, I'll kind of respond to some of what you're saying there, because I like this direction that we're talking about. I don't know if I don't really know if the cluster, like this is probably something we need to discuss with the main community. Like, is the community amenable to creating these type of objects that it's like, okay, a Karpenter infrastructure template is going to be a very specific kind of thing, right? That talks to, that one application that this API object works for. So that, does it make sense maybe for that to be something more generic? Like instead of, like a Karpenter machine template, is this something that we call like a multiple machine template or, something along that? Where the idea here is that we're capturing the functionality of combining all this stuff together, not necessarily the name. Yeah, Mike, please.
Does that end up putting us in a situation though, where we end up having basically duplication of the same manifest for both what Karpenter requires and what Cluster API requires with the exact same info? Or are you suggesting that we create one that automatically creates the other?
That's an interesting thought about the automatic creation. I think you're right, though. There might be a little bit of duplication. But yeah, if there were some way to like keep the regular infrastructure templates you have, but then have a collection that could like point to them or something, that might actually be a good way to look at this too. Jack, oh, sorry, go ahead, Mike, finish up. Yeah, sorry.
Yeah, well, yeah, I think to Mike T's point, I think that the idea is that the Karpenter CAPI provider, whatever that is, would be responsible at runtime for creating the necessary last mile set of CAPI resources for the specific provider that it's responsible for to create the actual infra. So that's what the Karpenter CAPI provider is going to do. So you create your cluster and you give it the necessary Karpenter specification, so that Karpenter will then go when the necessary operational conditions arrive to create the actual infra on your behalf. So I don't think you have to like pre-scaffold all that stuff. That stuff should be what the Karpenter provider does. I actually wanted to kick it over to Jonathan or someone on the current Karpenter core maintainer team about what is the lift for creating it. So if we're talking about a kind of pan CAPI provider, Karpenter provider, so it works with Azure and everything. If you've got a CAPI provider, then you get the Karpenter stuff for free. Environment like that is definitely going to look like you've got all your CAPI controllers running on the cluster. You've got a Karpenter core controller, which is now communicating with CAPI in some well-defined way. I think that's quite a bit different than the current provider operational model, or am I wrong about that?
No, that's true. I guess how I was thinking about it, and you can correct me if like maybe my perception of this is wrong, is that like would the provider implementation not just map like the creation of node claims onto the orchestration of the creation of machines from the CAPI side? Or is that just, are we just
That
talking?
could, if that's the communication medium, then I think that would be the path forward. Yeah.
Yeah, I mean, that's like one mechanism that requires us to like build out a full, I mean, you know the current state of the code, right, Jack? So like we'd have to build out a full separate binary rather than having some sort of like gRPC or like API based communication mechanism, at least in the current state of the code today. Like if the CAPI provider was built, it would have to implement the cloud provider API contract. And then like similar to the Azure Carpenter implementation or the AWS Carpenter implementation, we could just like ship a binary that was responsible for orchestrating the creation of like responding to the creation of node claims and then generating machines that CAPI can understand. I guess
That makes sense. So it actually would be, I was thinking something more like there's a single core controller, and they're communicating essentially in the Kubernetes application space.
yeah.
They're sending messages back and forth with CAPI, but you're actually saying that the better way to do it would be to create a lightweight CAPI provider and then compile link at runtime a single binary, and then the CAPI provider running with Carpenter. So essentially the Carpenter flavor or the CAPI flavor of Carpenter running in your CAPI cluster would then emit node claims, which changes to CAPI could be implemented to understand and then appropriately go actually do work on. Maybe I'm sure
yeah,
I'm simplifying things, but
maybe not even like changes to CAPI itself, like just mechanism within the cloud provider implementation for CAPI that was responsible for like looking at the creation of these node claims and then orchestrate. Like there's a create API within Carpenter, which is enforced by the cloud provider contract that Carpenter has. And as part of that create API, like basically what happens on the Carpenter core side is you get a reconciliation whenever there's a node claim created by Carpenter. And so that node claim creation would call that cloud provider create API, which then tells the cloud provider like, do whatever you want to orchestrate the creation of this thing. And so from the CAPI side, like you could just orchestrate the creation of a machine object under the hood that injects all the relevant settings. And then that, you get some response back from CAPI eventually that tells you that the thing has been provisioned, and then you can then leverage that back into the Carpenter core. I'm not necessarily saying that's like a better, like than having like a gRPC based communication mechanism similar to like how Gateway API has laid it out, where there's like kind of separate controllers for each of the cloud providers, and then there'd be a separate controller for like the Carpenter core mechanism. I just kind of, I guess my perception is that's a completely decoupled conversation. Like that re-architecture would be nice potentially, but I think it's also not necessary for us to implement CAPI with Carpenter.
So I had a quick question here, because this was something that I had wondered about, and now that you're talking about it, it makes me wonder more. So are the node claims, is that actually a CRD that gets applied to the cluster? Okay, because this is kind of what I was wondering. Yeah, it's like if we were able to set up, like going back to kind of what we were talking about before with the, like we have some way to collect the machine templates, right? And then when you're configuring Carpenter, you set up, I forget what the Carpenter terminology is, but there's that piece of information where you tell it like, these are the kind of provisioning requirements that I want you to have. Like, these are the machine types you can use, the kind of the inventory, right? So like if a CAPI user has a bunch of has a machine deployment that contains some special object that has a bunch of infrastructure types, and they can say to Carpenter, when I set up Carpenter, these are the instance types you know about. And then when Carpenter wants to make something, it makes the node claim. And then we have a CAPI controller that can take the node claim. It understands what to do with the infrastructure template that it's got there, and it stamps out a new machine that is part of the machine deployment. That sounds like the pathway that kind of I've been thinking about. Does that make sense though? Like, could that work?
Can you create, this is something I don't know. Can you create standalone machines in CAPI or no?
I know that you can make a machine, and you can make a machine object and add it. Normally the machine objects don't get re-reconciled like once you update them or something like that. So like I know you can create those objects and they exist there, and the controller will see it.
And
if you're creating it,
like it
yeah.
will launch it. Okay.
Yeah, it will launch it, right? Yeah.
I guess, yeah, I'm curious why we need the machine deployment at all then. Like, it is the space of instance type options just defined from the Carpenter side. And then like you don't, I think you kind of remove the need for a machine deployment on Cappy's side, right? Like we're really talking about just leveraging the existing Cappy bootstrapping logic. That's my understanding. And so
That's my understanding. I just want to clarify. I agree with that, Jonathan. So there's not like zero work to be done, but all of the boilerplate provisioning stuff that each provider has to do, and that AKS and AWS/EKS have done for Carpenter, it would just be super lame if that had to be maintained in two separate places or three separate places. So yes, you're right. That's what I'm trying to investigate is how do we use the existing AWS provider for Cappy, which has all that boilerplate, calls all the AWS APIs, can create VMs, can attach load balancers, blah, blah, blah. We want to take advantage of that.
Yeah, to me, this is going to be this to me is like from a marketing PR perspective, I think this is the biggest point against Cappy, like a Cappy specific provider, right? Is that a Cappy specific provider is going to be limited by the fact that we are creating an abstraction that exists for all of the providers that participate with the Cappy API. And that means that I think like if you were running Carpenter on Cappy AWS, that would probably look a lot different than if you were running Carpenter on just AWS EKS or something, right? Because I don't think there's integration in like the cluster API AWS provider to hook into like EC2 Fleet, for example, right? So like that, I think those type of interactions, we might need to just be clear to our users that like, you're never going to get those type of super deep integrations in the state of this currently, because it has to talk through like the Cappy objects and the Cappy abstractions.
yeah. Sorry, I'll let you go, Jack.
Cool, Jack.
Well,
please.
I'm not sure I entirely agree with that. I do agree that there's probably more sophistication in the Carpenter EKS provider than there is in Kappa. But I think that's not like a architectural thing. That's just there are more eyeballs, more muscle on the Carpenter, the AWS Carpenter provider than there is on Kappa currently. But I think that can be I think that can be reconciled. But
okay.
It's totally possible that if a year from now we ship a Carpenter provider, that the value proposition is larger for other cloud providers and less for AWS. For AWS, right. It's like, yeah, the Carpenter, the original provider is actually the better option for most AWS users, unless you're, Cappy first and then Infra second. Right. If you're Cappy and you're multi-cloud, maybe the value delta between the Carpenter AWS provider and a Cappy Carpenter provider leveraging Kappa is acceptable because it's super important for you to be on Cappy. But I'm expressing all this to say that I think I'm not convinced that there are architectural advantages in terms of provisioning for one or the other. I think it would be totally possible to implement the equivalent fleet foo in Kappa that exists in the Carpenter provider. It's just, I agree with Mike, it's probably not there right now based on my superficial understanding of the Kappa implementation at present.
Yeah. Jonathan, please go ahead. We have 5 minutes left. Just heads up.
Yeah, I guess we're talking about two different things in my head. Like on one side, we're talking about like what's the quickest way to get to a Cappy implementation, like a Cappy cloud provider implementation that would, like, this is one option that would leverage the existing Cappy machines and the existing Cappy bootstrapping logic and would kind of shim that behavior from Carpenter's side. So you'd get like duplicate objects in a way because you'd have node claims getting created that give you instance type options and a bunch of other detail. And then that would then generate machines. I think the ideal state of the world is what Jack is describing, which I agree with, but I think we need to enumerate effectively the differences between the assumptions that Cappy makes about how it orchestrates machine launch and the assumptions that Carpenter makes around like node claim lifecycle. Because that's effectively the difference today. If Cappy had the ability to, like, if we both reasoned in terms of the same API object for how we say, I want, an instance type of this shape, then we now can just layer like Cappy constructs on top of that same object that Carpenter layers constructs on top of. And now we've just defined an API object, which is a node claim or a machine or whatever we want to call it, that is just a representation in Kubernetes that says, give me something that is of this shape, and then I have installed a cloud provider based reconciliation mechanism for launching that thing. And I think that's like the vision that we kind of had as well for Karpenter was, and just generally for node provisioning, is that you can just declaratively define like a launch, which is kind of why we called it a node claim in general, was like, I just like, ideally the behavior in Kubernetes is that you've installed a controller that can just reason about a declarative install or the declarative launch of a machine in whatever cloud provider, and you just say, I want it, and then it eventually reconciles and joins, and then you have those concepts that meld. And so, and I think we're kind of solving the same problem, but just in slightly different ways. But it feels like we can layer that, like a foundational concept, or we can create a foundational concept and then layer additional ideas on top of it, which are both Cappy and Karpenter based on how they want to, like how we want to define that declarative creation of those things.
I think what you're saying makes a lot of sense to me. And I think as a starting point, having a Cappy controller that can kind of understand the node claim and then react to it, because if I understand correctly, like the node claim that comes is using all metadata that the user has configured Karpenter with to begin with. So when the node claim comes in, like it should be using information that's all pretty much known by the user and by cluster API. So there's probably a way that we could interpret the node claim and then turn that into, what Karpenter wants to see happen. That's kind of what I'm hoping. And Jack's got a point in chat here. It says, the more Jonathan talks, the more I tend to agree that do we really want a machine deployment? I think that's a great question.
I honestly wonder if maybe the right way to think about this from a high level is that Karpenter actually replaces Cappy Controller Manager altogether. And Cappy Controller Manager becomes a library. The Cappy components become a library for the particular installed providers so they can do their work. But the orchestration actor is no longer Cappy, it's actually Karpenter, if that makes sense. So from Cappy's perspective, it might be the easiest to assume that we are actually creating, from Cappy's perspective again, like orphaned machines, things like that. Like Cappy has no enforcement domain over them because they've been created by Karpenter. But Cappy is super critical in this world we're describing because Cappy is needed for Kappa and CapG and CapZ to be able to do their work. Like you can't just install CapZ, you got to have them both. That's just the way the architecture shakes out. But from doing all the things you were describing, Jonathan, about doing work, that all that declarative eventual consistency, trying to have Karpenter and Cappy agree on a common model for that is really kind of mind-bending. I don't see how that can happen gracefully. That's where things like mode come, like you might be able to put in a bunch of properties that essentially say, short circuit equals true. Like don't actually, here's a thing, you'll notice it, but don't actually do anything. So you question like, why do we have that thing if the thing is being consumed and then sort of like just no opt on every reconcile loop?
So we're at the bottom of the hour. I like the way this discussion is going. I'm going to keep investigating this from my side. I think like what I want to look at is like, can we do something where like a node claim is interpreted and then we just make orphan machines, and maybe that's kind of where we start and just see like what that looks like. And then I think we need to talk to the wider community to say, hey, look, when you're using Karpenter, you might be in this situation where you're just seeing machines. And I think if we could get to a point where like we could configure Karpenter in a way where it could understand the infrastructure machine templates as the inputs of the instance types and come out with node claims that are using those infrastructure templates or those infrastructure objects as like the instance types, then I think we actually could probably come to a middle point where there would be a generic Cappy controller that could make those things based on the node claim. So that's kind of the direction that I think I'm going to start going in, before our next meeting. So with that, I don't know if anybody has any other parting words they want to add on here, but thanks everyone for coming out, and I guess have a good holiday and a new year, and we'll keep pushing forward with this.
Yeah, I just had something to think about for the new year. I'd be willing to meet weekly. It feels like we barely get to a cruising altitude and then we're gone for 2 weeks. So And I think maybe none of us are working on this full time. This is a super interesting, complicated surface area. And I think we need to somehow force this,
Yeah.
make progress quicker.
I would say, like, I like what you're saying, Jack. I am actually working on this like full time right now. So I have some time to put into this. So like, I think getting to a weekly meeting, like maybe when we start building this controller that can understand node claims and start like making machines, maybe that's the point. Like we should start going to weekly so that we can actually design that as a group and work on it as a group and whatnot. So yeah, maybe in the new year, let's consider bumping this up to a weekly meeting, I guess. All right, we're 2 minutes over. Everyone's late for their next meeting. Thank you all for coming out, and yeah, have a good Happy New Year, Happy Holidays, everyone.
Thank you. You too.
Everyone.
Thank you.